Okay, so let's get started. I'm Jerry from CERIAS, and I just wanted to tell you how pleased I am to introduce our speaker for today. Dr. David Ebert is a Silicon Valley professor of electrical and computer engineering at Purdue, and he's also the interim director of CERIAS. So we're very pleased that he's here joining us today. He's also the director of the Vaccine Center, so he's got multiple experiences in lots of different aspects, and he earned his PhD in Computer and Information Sciences at The Ohio State University, and he currently performs research in visual analytics, volume rendering, illustrative visualization, and procedural abstract of complex massive data. So with that, I'll just turn it over to Dr. Eberts.
Thank you. So I'm going to talk probably a little bit different from the other topics that you've talked about so far in, let's see, don't know why that, what? It moved there, but interesting on where it's moving. So it didn't seem to be lining up. But what I'm going to be talking about is trustable information and how you can get information that you can rely on to actually make decisions. And to me, we have a really great opportunity to improve the effectiveness of decisions that people are making because of the fact that we have the availability of all of this data now that's coming in a digital form. Whether or not you're talking about sensed environments, you're talking about automated systems, new algorithms, things that are going on. And so there's a huge opportunity that's available today. And one of the things that people think is also a great thing to help us deal with that is deep learning as a way to deal with that data. However, I would tend to say that analytics and deep learning doesn't solve the problem of helping people make trusted and reliable decisions from information. There's a big gap from going from massive data to useful, reliable, and dependable information. And so it offers a great opportunity, but there's also a lot of things that we need to think of before getting there. And so one of the things to think about is, what is deep learning doing, right? It's taking a bunch of data that you provide as training data, it's coming up with a model, coming up with a deep neural network to allow you to then, as you get new examples in, be able to go ahead and find out what the best analysis of that is. And so as an example is the problem that I tend to face with most situations that real world public safety, homeland security people are dealing with is that new events aren't replicated in the past. Some things are pretty repeatable. Our predictive crime analytics tends to work fairly effectively, and we can give people a really good location. Some security software just deployed in Florida. The people who are using it for scheduling the way they were doing things said using the software, they found 11 incidents in the past week that they didn't think they would have found using the previous way they were doing patrolling, things like this. But oftentimes there are events that aren't in the data that you can't find. And so it's, how do you do machine learning to actually handle something like a black swan event? So I don't know, but just going to check something once. There's some, oh, there we go. It's not, I guess I'll use the mouse to move forward because a lot of things weren't showing up that were supposed to be on the slides. So as an example of what, where deep learning doesn't work is, how do you handle situations that aren't being trained properly? So for instance, this picture being classified saying it's a boy holding a baseball bat. Based on the training data, that was the closest thing that it found. This was the output, because where machine learning is done so well is in doing classification of images from large-scale trained data sets. And the problem is, in this case, you know yourself that the algorithm's wrong, but when it's a problem where it isn't obvious to you to look at it that it's a mistake, when do you know it's right and when do you know it's wrong? You know, what goes into that training data is so important. Any biases, any misleading information that's in there can really screw up the algorithms. And the one thing that will help it is you get more data integrated that improves the amount of training data that's there, it does work better. The other problem is knowing what is the algorithm actually doing. So there's a big problem right now with all of the deep learning algorithms where people don't understand the algorithms. They don't understand how to optimize them, for one thing, but they don't know whether to trust them under which situations, and under which situations which different models will work the best, right? So there's been a lot of work in my area in interactive data visualization and analytics and creating visualizations to help you understand the training network and be able to look at it, because it's too complex to really look at otherwise. There's also work trying to bring semantics into the data learning algorithms to help with that. And so there's a way to bring in also science-based models into the ensemble of different components that you bring together that may relate to the problem you're trying to address. So when you start bringing all of these things together, you can improve what's going on in deep learning. But it doesn't help you come up with trustable, reliable information when only part of the data is digital, and know whether or not you've got the complete picture. Was there a problem in the training data? You really need, for effective decision making, you need a combination of the human expertise of the problem that's being solved, as well as insights from the digital data. And so that's what's needed to make the most effective use of information that's coming in, and to really turn that raw data into usable, reliable, trustable information. And there's a lot of complex situations where it doesn't tend to work effectively, and it really depends on the type of the data, right? If you're talking about sales data and customer trends, you can do really great jobs with machine learning and predict behavior. It's how all pricing and marketing is done now. But when you have data that's more qualitative, it's fuzzy, it's incomplete, it's opinion-based data, the algorithms aren't very good at handling that. Also, when context is important, you have a problem that the entire context may not be in the data. And two examples that I've come across over the past few years working with people is one in a public health official in Montgomery County, Maryland, whose job is finding unusual health events every day. So one of the data sets that they get in is absenteeism reports from all the local schools. He got in a statistic one day that 80% of the senior class was missing from the one local high school. His wife happened to be an emergency department nurse, called her up and said, "Are you seeing any kids coming in who are ill, because we've got 80% of the senior class out? And I'm trying to decide whether I should issue a health alert." And well, what was going on? It was senior skip day. You know, she said, "It's senior skip day, stupid, not, you know, ignore it." But he didn't have that context. Another example from the admiral that was in charge of the response for the Deepwater Horizon oil spill, he was trying to figure out how much 12-inch skimming boom they had available that they could bring in to try to contain the oil spill. So when he was on scene, he said, you know, what do we have from the nearby stations that we can bring and have in here within a day to solve the problem? So they went into the database, queried all the emergency plans of all the local stations, and they came up with hundreds to thousands of miles of 12-inch skimming boom. And it's like, well, that can't be right. You know, how could there be that much available because it's used so infrequently? Well, everyone in their contingency plan had to go in and say, you know, if I have a spill, how much 12-inch boom can I get in here within 24 hours? So they called up their suppliers and they said, what can you get me? But everyone called the same suppliers. So you actually had like 100-fold increase in the amount that was available because it was all coming from a handful of suppliers. So the human in the loop knew that was a problem, but the analytics in the system had no idea. So you really do need that context and understanding the data and the provenance of the data. And also, as you know, as you get more and more data, you end up having it being more difficult to tell between spurious and insignificant events, right? In n-dimensional space, when you bring in more data sets, everything is equally distant, statistics falls down, similarity measures don't work. And the final problem where we've really run into a lot of things is when people are integrating systems across multiple scales, the algorithms don't adapt across that, and traditional analytics fall down. And you need to understand these multiple scale systems. So that's a problem that runs into creating the need for having this pairing of data-driven science-based models with the automated advanced statistical and learning algorithms and the human in the loop to really get a correct solution to the problem. And so you're really trying to make that pairing of what a human does and what the computer does effectively. And when you do that, you end up being able to give people trustable, reliable, quantitative, and explorable and verifiable information to make their decisions. You can allow them to become more effective in doing their job, and you can increase the efficiency of what they're doing. And so the goal of the systems we've developed over the past 8 to 10 years have really been in giving people the right information that's reproducible and reliable in the right amount of time that they have to do the problem in a format of whatever they're working in to solve it. And so that's really the key to this. And I always use the example that I want the information that someone's getting, they can explore what's causing it, what are the factors that go into the solution, because I've had numerous times talking to people from police officers to Coast Guard to government agency personnel when we're running and doing analysis and giving them a tool to look at their data. If we're telling them something's going to happen, the response is either, I knew that, what's so good about your system? It's obvious that that was going to occur. Or if it's not what they expected, the first question is why? Why are you saying this is going to happen? And if you say, well, if you look at these 10,000 circuits in my neural network and you look at the parameters that were set, that's why. No one's going to understand it, right? You need something where you can say, it's this part of the data, these are the patterns, this is what's factoring into it, then they'll trust it. And I always say that I won't let a surgeon operate on me using a visualization program of the medical data unless I use the program and understand that they didn't set the parameters right, because I used to do medical visualization a long time ago in my career, because I know how different that image can be and how much error there can be in that. So you need to make sure that it's reliable and useful. And we also find that in so doing, you can apply it to a lot of different applications. So we've looked at applying these interactive ways of getting reliable information in multiple different situations. One of the things we've done is we've focused on how you can do interactive visual analytics for deep learning. It's been an active area, and this is an example of work in that area done by people from Google creating their TensorFlow Viz system to help people understand what's going on in TensorFlow. Our work in this area was actually looking at taking multiple models that you're running all of these different ensemble models to try to look at data coming in for autonomous vehicles and determine which algorithms give you the right predictive behavior for the car under which situations. And the goal is to get an ensemble of neural nets to work together and have the car drive without crashing. So we're really looking at which features and which of these different algorithms give you the correct information so that the analyst can then come up with the best ensemble model for this. So we're working with people from a company to actually increase the accuracy of this and be able to fit it together into a system that allowed them to get more accurate and reliable, in this case, non-crashing autonomous vehicles. And so that was quite effective. And so in summary, this idea of bringing the human and the computer together, some people are calling it human-computer collaborative decision-making. Some people are calling it mixed initiative or interactive deep learning. It also feeds into some of the work that's going into explainable AI, really does help with the problems that you're running in with some of the failures that machine learning and deep learning are having. Another area that this comes into play, and it really brings the human into the loop in their understanding, is in competitive business intelligence and other business applications. There's been a lot of work looking at bounded rationality and cognitive bias in decision making and why humans do terrible at economic decision making. So visualization and interactive explainable information can help people make those decisions. We've also been really fortunate. A tough problem that I've had the opportunity to work on is risk-based visualization, where people are trying to measure the total risk, the mitigated risk, and the residual risk from their courses of action. Very few agencies have really good risk models and model the risk of everything they do. The U.S. Coast Guard, every decision from whether to launch a boat on patrol up to high-level resource allocation, there's a risk model associated with it. So we've helped them by creating tools to help them evaluate the risk and look at where they're buying down the most risk for the use of their resources. We've also done work in competitive intelligence in corporations and helping them develop these systems to really understand and rely on the data. And we've also done some interesting work in financial security in creating a system to allow people to determine if there's unusual market activity, whatever type of market it is, credit default swaps, looking at other things with banks, looking at stock markets. If there's unusual patterns in the data, first of all, can we find those patterns? And secondly, can we tell if the available sources of information in the public explain that example of what's going on? So we combined, working with analysts, we combined a bunch of different visual representations to create a system to allow them to drill down and annotate and track where the anomalies were, what were the patterns in the anomalies, and look at news sources related to those to see if they're explainable. So as an example, let's say IBM stock shoots up, all of the other tech sector stocks go down. So the question is that something that could have been predicted? Is there something that explains it? Or if there's not something that explains it, why did it occur? Is it something related to insider information, other activities that are going on? Or there's lots of different scenarios at higher level organizations where patterns in financial activity can give you a bigger picture of what's going on. So again, it's this case of understanding and bringing information sources together, because the same piece of information might be significant and indicate a problem you need to investigate, or it may be easily explained by the events that are going on. So those are the type of situations that can be quite interesting to explore. And so that's the system that we developed, where you can look at different components from time series anomalies, zoom into individual components, look at comparison, in this case, of all the stocks in a sector to see if you're seeing unusual activity, look at when the anomalies occur during the week, and look at the topical stream of news stories relating to what you're looking at. So again, a way to bring all of that in to try to understand it. But with all of these, what we really try to do is help people make risk-based or reasoned decisions. And we've done it for a lot of Homeland Security applications, looking at resource allocation, looking at return on investment from the very highest level, creating a tool used by the Atlantic Commander of the U.S. Coast Guard for understanding resource allocation and planning over a 6-month period, to very low-scale handheld tools that are used by police officers in understanding where they should patrol and the effectiveness of what they're doing. And as an example for the U.S. Coast Guard, here's a case of our CERIAS system. The Government Accounting Office determined that our tool, with the decisions based on it, would save the Coast Guard over $180 million in 10 years in resource allocation. It was also used after Superstorm Sandy hit the New York, New Jersey area to decide the response and assets that were needed. They didn't know how to integrate the data and say, since there was so much damage done, 17 Coast Guard stations were destroyed, what presence do they have to have there to make the waterway safe and navigable? And so using our system, instead of having all these people scurrying for a couple of days to get data, someone in the meeting said, well, we can just pull up the data in CERIAS and be able to go through and look at what's going on. So they pulled up all of the search and rescue cases for the past 3 years that occurred in the month of November in the New York, New Jersey area. They were able to find there were very few cases that actually occurred. They looked at them and saw they were all from recreational vehicles, recreational boat vessels, and people didn't have RVs out in the harbor. But and they knew that after Sandy went through, there were no boaters out there because of all the damage that occurred. So they came back and they scaled back their response and saved putting a lot of people at risk, as well as saved a lot of money in their response to that. We've also allowed them, they use the tool as well to optimize how to rebuild the stations and what capacity they needed based on looking at the data. Of course, the first time we gave them this system, what they found was all the holes in their data, because the first thing that you see is all the incorrect information whenever you create a visualization of the data. And the one thing that we do to make sure they know how to trust it is we tell them what % of any prediction or any visualization is based on data that was valid. One of the things we added to our system was the ability to flip the latitude and longitude to get the search and rescue cases into the continental United States. Because if you looked at cases that occurred in the Great Lakes District, you actually found that if you flipped the globe around in Kazakhstan, you saw an outline of the Great Lakes because people had the latitude and longitude wrong. And so we would put checks in there to try to correct. A lot of people who use systems that people are doing analysis on don't want to spend the time to enter the data in. They want to go back and do their normal job. So if they can hit 0, they hit 0. So there's a lot of crime from a lot of departments we looked at that always occur at midnight because 0 is the default, and so they just hit return and never put the time in. We found working with one agency that 65% of the cases to 80%, depending on which year, had no time of occurrence in there. So if you're trying to decide where you should be in the morning and the evening, you don't have that data. But the other thing we allowed them to do is look at the efficiency. In this case, how many boats could be on scene if an incident occurred, how many could be on scene within 90 minutes, which is sort of their goal that they have. And so with this, with the potential laydown of assets, you can actually see that there's large parts of the Great Lakes where you could have 4 assets on scene, which really is much beyond the safety standard that they want to have. So it's probably not the most optimal use of resources. That system was developed in a 2-week period based on our crime analytics tool that we developed. And what started it was someone saying that the Coast Guard was having this problem, that the Coast Guard Auxiliary was basically dying off. They're retiring. They're dying, no longer able to go out and assist. In a large part of the U.S., they have a 3 times force multiplier in the summer of retired Coast Guard and Navy personnel in the Coast Guard Auxiliary doing patrols and doing simple tasks. And so an admiral wanted to know, how am I going to keep the Great Lakes safe? If I lose all of these, where am I going to have to do that? The other thing that comes up in seeing the data and not understanding the data and not understanding statistics that the visualization could potentially mislead you is, if we put a picture up of where do all the DUIs occur in West Lafayette, Indiana, what you're not finding is where all the driving while intoxicated is occurring. You're finding where have the police caught people driving while intoxicated, right? So there could be areas that they never patrolled that are terribly dangerous because there's all kind of drivers who are drunk, but they never go there. And so you really need to understand what you're doing. So our crime analytics software is very similar to that. Again, it's this interactive way of doing advanced data analysis without having to do any programming or understanding advanced statistics. So you have a map-based view, which shows you all the incidents and where they occurred. You have a time window view. You have a clock view, and all of these are selectable. You draw a region on the map, all of the statistics change. You select times of day on the clock wheel, and it only shows you crimes occurring there. You can also look at the calendar view, and by having the histogram at the bottom and the side, you can see if there's any day of week patterns that are occurring. All of these things into it. You can filter and select, and you can choose the aggregation level, day of week, daily information, weekly, monthly, yearly. You can seamlessly scroll through time, and you can also go through and do prediction based on the patterns of a certain type of crime, how many crimes do I predict for the next 5 days? So that's all built into the system. And again, as an example here, if you say, I want to select this particular day, bring up more information on those cases, I can also choose all the crimes that occurred in a month at 3 p.m. I can choose all the crimes that occurred at 3 p.m. on Tuesdays and find out what's going on. So again, it's a way to get that data in there to increase the effectiveness, but making sure that the data is trustable and reliable. We've done similar things in trying to bring this up to performance analysis of employees, where we have the police that are trying to determine the best team for a given area on a given shift to make the community the safest. And so can you bring in supervisor information? Can you bring in actual crime report data and determine whether or not the metrics that you've set up for your team actually reflect the way that they're performing in your impression of their performance? So can we come up with a way of getting weighting of the crime and tasks that people do for the importance of it? Can we bring it in, look at the statistics? What is that telling you about your officers and how it varies across the area of town that they're working in, and the time of day that they're working, because they're going to have different workloads, and actually go ahead and create more effective deployment of police officers. And so this is something that's been used quite effectively for improving the understanding of top performing officers. Do we have the right people on the right areas in town to make things most effectively? We have, as you've sort of guessed from these examples, done a lot of work with federal agencies and local and state agencies in public safety, homeland security, and preventing crime. One of the things that we were asked to do, all of these tools that we developed in trying to help them get more effective, reliable information, really come from meeting with our first responder partners, or meeting with them on a monthly to quarterly basis, hearing what problems they have, what they want to do. And the tool that we developed, called the Social Media Analytics and Reporting Toolkit, or SMART, is one of those tools that came up from a conversation with a police chief saying, you know, we have a Facebook page that people can post if they find something, in a Twitter account they can send things to us, but how can we actually use social media to get a better situational awareness of what's going on? And so we came up with an interactive toolkit for allowing them to do this. It started back in 2013. The version that we have now was just used yesterday for the State of the Union address by security personnel. And they found, the good thing is that our tool seemed to be value. They found a lot of things that they investigated from that to help keep things safe. The biggest event, I guess, it's probably been used at, well, it depends who you believe in terms of the size of the crowd, was the presidential inauguration, where they used it. And for us, it was a really good example of the use of the tool, because so many groups were protesting using social media. So the general alerts that we set in of how many tweets within so many minutes will send you an email message that this topic has come up. When we turned it on, we're using 10 tweets within 5 minutes, which seemed to work fine for when security personnel used it at Ohio State home football games. That my inbox didn't scroll up, but when we turned on the filters 2 days before the inauguration, my inbox just started scrolling, because we kept on we were getting hundreds of tweets per minute coming in, setting off the filters. And so it has been used effectively for a lot of large-scale events. It allows you to really target and find information, because we allow you to get at the linked information. So we think of it as a way to crowdsource information of what's going on in a community and help you make sure you're not missing what's going on. So we have applied it to the Umpqua Community College shooting up in Washington. It's been used in that case to help you see the patterns of where people are gathering, what are they tweeting about with these interactive content lenses. All of this is updated in real time. So within a few seconds of a Twitter message being posted, we do topic analysis, classification, can show it up on the screen and put it in and run it through filters. So you've got the classifiers here that allow you to filter things down. You've got the LDA topic analysis topics that come up. You've got the content lens. You've got a message table where you can actually click on the message and follow it and pull up information. So you can pull up this linked image of a memorial that was being done for the victims after that shooting. It's been used in this sort of passive mode, as I mentioned, of giving you an alert. And for one of the people we were working with, I'm like, you get a couple messages coming through per day. I get CC'd on them just to see if our tool's working right. I haven't seen anything that's important. Do you still want to have them turned on? And he said, definitely, because someone had tweeted, I've honestly considered shooting up the school. And so that was something that he passed along to law enforcement. During a River Fest in Louisville, Kentucky, a week-long celebration, there was also someone who said, everyone skip schools. A certain person was going to threaten to go in and shoot up the school tomorrow and retweeted that tweet. And in that case, they started looking at the people's information. They found credible evidence, interviewed them, and luckily in both of these cases, nothing ever happened. But again, it allows you to get more information, and we allow you to see how the topics and interests in a community flow over time and across regions. So you can actually go in and look at the different topics, look at where they're going across the community and which keywords are triggering things. So you can see in some area that shoot, arrest, and riot is really coming up high, where in another area it's more ambulance, SWAT, and cop that are the top topics that are occurring. So it's a way for you to, again, interactively monitor things. It's been used after a number of hurricanes have made U.S. landfall to find people in need and determine what the response has been. So here's just some examples where you can see what people are tweeting about in real time. Pull up images that they list so you can see whether or not there's power outage or flooding that's occurring. This is an indication of what was going on in Hurricane Harvey, Hurricane Florence. So again, it's a way to get this information and be able to understand it in easy to use manner. And this is an example from the inauguration where you can see the type of information that in groups that were protesting. You can actually pull up videos where a reporter was pushed down and was knocked down accidentally. And you can also pull up images seeing, are your police responding appropriately? Are they just keeping things safe and situations aren't getting out of hand? You can get information such as this tweet saying 6 out of 12 of the entrances to the mall have been blocked by protesters, so crowds couldn't get in, so you know where to deploy things. In the use of our system, what we've been told at command centers is people were able to get information 5 to 10 minutes quicker using this tool than the rest of the people from the other sources feeding into these command centers. And these have been fairly advanced intelligence command centers. So that shows that there is an ability to take, and all of this is publicly available tweets that you could search on Twitter and pull down yourself. This is all just what people put out there, which personally I don't understand why people post so much stuff on Twitter, but it does allow good sources. We do Twitter, Instagram, etc. And so you can get all of that information and see it. What we've actually done now is tried to see, is there a way for us to improve these simple keyword filters and make the information more reliable? Because Twitter messages are so small, you can't do advanced semantic analysis because you've only got 280 characters. So it's a lot of syntactic keyword-based analysis that we do for the classifiers. But we've now decided, what we've implemented in our beta testing is interactive machine learning using an LSTM model, so that we have a very shallow network that we can evaluate 1,000 tweets within 2 seconds, so that there's not a lot of user slowdown in doing it, and we incrementally train it so that when you first start using the system, we've classified the Twitter messages as relevant or not relevant, but you can go in here and click relevant or not relevant, provide the feedback. This is giving you a confidence score of whether or not our classifier has a high confidence or not. And from doing that, within a few seconds to a minute, the classifier will have retrained and you will no longer see those messages that you say are irrelevant. And so this is a way to bring the human in the loop and actually do that incremental machine learning and that human-guided machine learning. And it's something that all of our just presented to a group of first responders this morning in their command center, and they're very excited to have that added into it. So again, it's a way to bring all of the advanced analytics into a system with the human so that you can get rid of some of the problems. Because most deep learning networks, if you want to retrain them, I know for one project we're doing, the training takes 80 hours to train the model. So if you've got new data, you're going to have to wait several days before you're going to see that feedback. And so we really can't have that in an interactive environment. To give you an idea of how this stuff can transfer into deployed tools, an example, a lot of the research we did here went into the forming of a startup company out of Purdue. I don't know if any of you have entrepreneurial spirit, but Purdue's Foundry is great to help students, staff, faculty form companies. And the Heimdall system is for property security. It takes all different sources of data in and helps tell you where the greatest threats are, help you schedule security patrols, camera patrols, etc. for those environments. And so it's been deployed at a number of environments. And as I mentioned, a new place it was deployed last week, we got the feedback that they found 11 incidents they didn't think they would have found otherwise. So this is looking at foot traffic pattern, looking at reports of from owners at a property or the tenants at the property, looking at crime reports in the community, other type of social media, other type of community information that feeds into this. And so again, that's a way to bring it into a system to help the security personnel optimize what they're doing. So what I've been really trying to focus on is that when you start combining the human and the automated techniques together, you're able to get an increased reliable system. You're able to complement what the human's good at and bring these algorithms in. And you can create these effective environments. You can make sure that the information that people are using is trustable, reliable, and reproducible. And it works out that it allows people to get really useful information. And I think this combination, and when, I don't know if any of you were able to see the Vice President of AI and Quantum Computing from IBM give a talk, I think a week ago Friday. I was able to meet with him in the morning, and he's a firm believer that explainable AI, interactive AI is needed for the success of deep learning algorithms. And there had been a bit of a backlash. I know a lot of government agencies that spent huge amounts of money getting more traditional machine learning algorithms and big data analytics that they tried applying, and they were complete failures because events that are occurring were not in the training data set. And so after a couple months, they stopped using this, even though they may have spent $500,000, $750,000 on the software. It didn't perform, so they went back to doing things the way they were. This human in the loop really will enable, I think in the next 5 years, will show the promise and actual value of what a lot of companies are touting as deep learning being able to do now. So I think there's a little gap between, which isn't surprising, between the commercial hype and the reality and value of what's there. And this happens all the time. So I think we really need this explainable, trustable information for effective security operations. And knowing the training data, knowing the information that's going in is also very important in computer security, because as you're trying to bring AI algorithms in to analyze what's going on, you need to make sure that your neural nets are trained on the right things. There's no either intentional or unintentional bias into what's going on. And so the visual and human in the loop can really help you with that. Because as training data sets get larger and larger, how do you, the trustability of the training data set that directly relates to the effectiveness of the algorithm is hard to justify. And so I see this in security applications. There's also this strong concern in a lot of different areas, from health and medicine to agriculture and things. I gave a talk last week on what the future of computer technology is on perennial crops and what's going to happen, and is it going to solve the labor shortage? And someone was saying, well, deep learning is going to allow us to have these tools. We won't need skilled labor. All of the equipment will be mechanized, and our labor shortage will go away. And unfortunately, I was quoted after the vice president in an article after the vice president of Vineyards from E.J. Gallo, who said, this will be, a solved problem in a year or two once the algorithms are there. I said, it's going to take a lot longer before you really get the algorithms that don't require the expertise to know whether they're working and when they're working. And it really is a case of needing the human in the loop for the near term. And I don't see that going away. And it seems that a lot of the people who are leaders in this field are starting to take that approach and bring that in and work out that human side of things. So with that, I'm happy to take any questions.
Any questions?
Yes?
Did you look at any of the other
Go ahead and use your microphone.
Oh, sorry.
when developing the smart software, at least, did you use or look at any of the other open source intelligence gathering tools that were out there, like the one written in Python? I think it's called Creepy.
So I'm not sure that that was available when we started 6 years ago. We've looked at most of the commercial tools that are out there. And, one department was using a tool at the time, I'm not even sure if it's still there, called Twitterfall and other things. So what we've focused on, and our tool at one point read in all the publicly available Facebook posts. We can read in YouTube data and look at the metadata. Anything that's publicly available. Of course, so many companies are trying to, the problem with doing it now is that so many companies want to sell their data. And so, for instance, Facebook no longer has an API where you can directly get the public posts unless you're willing to pay for it. And just like with Twitter, if you want the entire Twitter data stream, if you want the fire hose, it's very expensive. And
use lots of different accounts.
well, but yeah, you could. But actually, we, with our smart tool, right now we have a number of departments using it for free. Department of Homeland Security has funded Purdue and DaVista to create a commercially available tool that a first responder could download to use once for $10 for the basic version. A police department could get it for an annual subscription of less than $10,000 per year and maybe a higher initial cost. And the question with doing that now, if you're going to Twitter and they're saying, if you want the whole data stream, it's hundreds of thousands of dollars. How many customers do you have so that you can actually afford the Twitter bill? Yeah. And so, but it's just being smart. And the good thing is, I guess it's just sales, right? They come up with all these different packages to make it easy for you to customize what data is coming in. So there's simple things you could filter out. You can do geographic areas depending on this. But we do try to get all that data in, and I've always said with most of the tools we try to create, we try to make them data agnostic, but really hooking them into someone's operational pipeline normally means we spend a huge amount of time hooking into their data schemas, et cetera.
Yeah, it makes sense. You're not going to have a local police station pay for the entire fire hose if they just
Right.
need their county,
Yeah, and so with that, I think there is, the company who is producing that is trying to work out a business model that as they add areas, they will get different portions of the data. And the Instagram data is also something that you can get now. When all this data will stop being available is a question, and what are the new sources? So we always try to see what's there, and you can actually find, we did studies looking at which of those publicly available data sources were good at finding different types of events. And with YouTube and some of the online picture websites that you can crawl, with those, there's such a lag for when they're updated that if it's a short-lived event, like a fire or an accident or a shooting event, that you really can't get useful information. But if you have a hurricane go through, a tsunami, blizzards, and you're looking, you find the pattern just as well there. And if you start combining multiple sources, you can find detailed problems by doing it. But it's interesting looking at the statistics across the different data sources to figure out how to put all this together.
So like in this model that you have, you assume that the humans are not malicious, right? So,
Yes, we do.
so if you have like a website where everyone can go in and label the data basically for you, there's always the chance that you can't really trust the humans.
Absolutely.
So, or like if I'm a malicious attacker, then I might try to like influence
Right.
your machine learning model by
Yes.
like
And
wrongly
so-
labeling the data.
Yeah,
You know?
what we're
So-
doing right now, this doesn't stop the insider threat, but if you create your own filter and we're training it to improve it, you set who has access to that. So in an organization, it can be organization specific, it can be shared among the community, and then with an organization, it can be on a team or an individual. So we would assume that for safety and security classifiers, you would only have internal people do it. Now, the other thing with the social media that we get asked a lot of times, I've talked at Fusion Center conferences, and a lot of different analysts from different agencies talk to me, and they're like, well, are you able to pull out misleading information from Twitter, or people who are trying to deceive you and get you to go to a location? And we have some work that we're starting. We're also, there hopefully will be a project starting where we look at that, as well as, so can you pull out the false news, as well as making it completely multilingual, where we do classification both in the native language and in the translated language in a unified corpus. Hopefully that NATO project will come through for doing that. But what we found in all the uses of the system, it doesn't mean it won't occur, but we haven't found any situation where people have used it where there's been a campaign by people to create false information on social media to mislead people and not respond to where the crisis was. So we haven't seen that yet. And that's why we sort of think of this as a crowdsourcing approach of, you're seeing information that's out there and you want to have your trusted people and your not trusted people that you're trying to decide whether or not you can investigate. And for instance, there's a software package called WebEOC that a lot of emergency operation command centers use. We're now working with the company Javari that makes that to integrate our smart system into there so they can get the reports of what the first responders on the street are seeing, but at a command center, you could also see what's going on in social media and you can compare it. Or you can say, people are reporting there's a fire here and this person's close by, do you see any indication? So you have that trust and verify. The other thing, we've had research projects actually looking at the influencers and the followers in the social networks that are forming and trying to determine the reliability of different people posting. If you look at Indiana, the most popular posting sites are people advertising jobs. When we headed up this morning, we were seeing all of these posts, like every 5 minutes there was a new McDonald's kept on posting about job opportunities. And so jobs really seem to be important, a large part of it, but you can decide, do you trust these reporters who are reporting it? There was a competition held to use social media data to predict of the new releases for a given week, which were going to be the top 5 movies, and which was going to be the most grossing movie. And what you found is there was a part at the top that were all accounts created by the movie studios. And so looking at the connections to these accounts, a former student was able to come up with a way to determine how to get rid of the people that were sort of just promoters versus the actual people who were reliable, giving personal reviews or information. They were really trying to say, what is the buzz? Who's going to go and see it, right? And the movie companies try to create that buzz, but if you get rid of that artificialness in the data and actually look at the patterns, they're able to get pretty accurate. So people are always trying to look at those things, but the trustability of it's a really important thing. And that happens with all this. Now, surprisingly, there is a lot of, there's services for people can post something to a group of volunteers on social media to provide them answers to help them with their daily life. If they, for instance, there's a service of people who are visually impaired, and they don't have Braille on whatever they're doing can take a picture and send it out to this crowd and get an answer back within a minute telling them what's going on. So they say, does this tie look okay with this shirt? For instance, it's something that they might not want to bother a friend with, but they're fine with putting it out to the crowd, or they buy something that doesn't have microwave directions that they can read in Braille. And they'll take a picture of it and post it. And I heard the people, they try to, rate people of how effective they've been, and if they don't respond or they don't give good information, they get them out. But this was like over a 99.5% accuracy. And so people actually rely, so my question was, could you trust what's coming in from the crowd? And there's been a lot of social experiments on it. What?
Not on Twitter, I would not trust it.
Okay, yeah. So those are the different ways. But there's plenty of good algorithms out there to mislead people. And the question is, can you actually find those patterns? So our approach for doing that is to look at the wording pattern and the followers and links to the ones that are fake. That, if a human says, we know this is incorrect or this is misleading, can we then find similar, are there characteristics that you can do with analysis to find similar things and get rid of them? Yes.
Yeah, I've noticed that it's pretty easy to find a bot network because they kind of move in clouds. They all follow each other and they move together. So you can kind of map these different groups of bots out. So if they all follow each other, it's all connected to this network and it's all pretty much the same thing.
Yeah.
But yeah, it's interesting. I feel like there needs to be a good algorithm that can look at an individual user and see if kind of like a social currency, they have the account's mostly on private, it's not promoting things, and it seems like basically trying to detect which person is a real person.
Right, and what are
not.
the patterns and
Yeah.
the frequency that they post, and how
They
many
post
reposts
often
they get from
sarcastic
it.
posts,
Yes.
and then you can kind of vague. Because I was talking to one of my friends who works in intelligence. His name's JL, but he worked on something very similar, and a celebrity posted about a possible shooting in a school, and he got the alert for it, and then 7 minutes later, the police, NYPD, got the alert. Same thing. They're like, "Oh, how'd you know?" He's like, the algorithm that I was working on before recognized him as a celebrity as a higher status since he was verified, and immediately got the alert.
Yeah, and one of the things, there's really good work going on here in the sociology department and communications department. Professor Soren Matei actually does a lot of, we've collaborated with him quite a bit to understand the social dynamics, and can you even tell why people are posting what they're posting? Is it because they just are trying to get rid of frustration? Are they really in danger? Looking at, for instance, crisis events, and why do these things come out, and understanding the follower-influencer relationship in these networks. And it's normally not the people who post the most who are the most influential and have the most followers. So trying to understand who can be the influencer, because if you are trying to get a message out, there was a problem we were given a number of years ago, where the question was, if you were giving someone guidance of how to evacuate the football stadium on their cell phone, and you told them to turn right and everyone else was, the crowd was going to the left, would they follow you or not? And understanding the dynamics of what it would take to make people trust that automated response versus the crowd and be a lemming. So, interesting. Okay.
Well, thank you
Thanks,
very much.
everyone.